Alright, 4.1. Chapter 4 in general has to do with polynomials. We're going to learn what a polynomial is. You've been working with polynomials your whole math career pretty much, but we're going to work more with polynomials, adding, subtracting, moving around the graph maybe a little bit, solving them, even multiplying, dividing them. So 4.1 lesson, we'll start with a little bit of vocabulary. So what is a polynomial? So I think it's best to just show you things that are polynomials and that are not polynomials. So if you want to grab your green sheets or whatever you need to write this down, yes, these are polynomials, and no, these are not. So polynomials are like quadratic equations we've been working with. So that's going to make a parabola. That's a polynomial. Lines are polynomials, 10x minus 1. We'll get into higher degree ones, like it might be 5x cubed. But that's also, it could be a fourth or fifth. As long as the exponent is a positive integer, then it's a polynomial. Ones that aren't polynomials, you might have like 3 over x plus 10x plus 1. So what's different about that one? Phoebe, why do you think that that is not a polynomial? Good. X is on the bottom. Very good. So if you are dividing by x, that's not a polynomial. So we could think of that as, this is actually 3x to the negative 1. That's another way of writing that same equation. So if you're dividing by an x, or if you have a negative exponent, that is not a polynomial. How about Destiny? What's different about that one, do you think? Good. Fraction as an exponent. Okay, so if we have a fraction as an exponent, it's not a polynomial. If I divide by x, it's not a polynomial. Or if it's a negative exponent, then it's not a polynomial. A fractional exponent, we could write it in different ways. We could say it's 5 square root of x plus 9. This is not a polynomial because we have a square root. So basically, it could be a cube root, could be a fourth root, but any of those roots not going to be a polynomial. Okay, so those are polynomials. We've dealt with polynomials a lot. This is a polynomial. I can have the square root of 3x cubed plus 10x minus 1. Okay, that's okay because the square root is just on the number. It's not on the x. So this coefficient is a square root of 3. We're still good. That's still a polynomial. But if it's square rooting the x, then it's not good. Alright, so more vocabulary. If we were asked to find what the degree is, it's the largest exponent on a polynomial. I sent out, some of you might have done the survey, and one common theme that I'm going to adjust, I saw it more than anything, was slow down. Most of you said that I explained it well, but I just need to slow down a little bit. So I'm consciously trying to slow down here. Alright, the degree largest exponent on a polynomial. Here's an example. If you're trying to find the degree of this, what do we think? Any ideas what the degree would be there? Somebody said it. 3. Who said that? I have no idea. Good, Robbie. Okay, so the degree is 3. That's your degree right there. The largest exponent on a polynomial, so the degree is 3. Sometimes they are not in like standard form, descending order, so don't be fooled. Lexi, what's my degree here? It's 4. Very good, because that is still the largest degree. A lot of times it's going to be the first term that has the largest degree, but in this case it's not in the right order. So the degree is 4. A lot of times I might ask you to put it in the right order. So descending order, you would just put the largest first, then the next largest, and so on. Okay, so the degree is 4. Leading coefficient. So coefficient is a number out in front of a term. Here's our example. Our leading coefficient here would be 7. So it's the number out in front of the largest degree. So if you put it in the right order, then it's just going to be the number out front. So the leading coefficient here would be 4, based on this number right there, not the degree. And the leading coefficient here would be, what's my leading coefficient? Who can I pick on? Jillian, what do you think? What's my leading coefficient here? 10. No? 8, right? So it's the leading coefficient right there. Very good. Okay, questions on that? You're going to have a formative assessment next week sometime, and that's about, well, that's a lot of what your CFA is going to be on. There's a little bit more that I'm going to talk about, but if you understand how to find the degree and how to find the leading coefficient, those are 2 of the questions that I'm going to ask you on the formative assessment, and I'll ask you on the test too. No questions so far? Alright, so I'm going to make kind of a little matrix array chart thing, starting with degree, and here's a sketch of a positive leading coefficient, and here's a sketch of a negative leading coefficient. Alright, for degree 0, I'm just going to kind of skip that one for now. It does follow the pattern, but it's kind of confusing to talk about what a degree 0 would be. So I'll just come back to that one. How about degree, or I might not. Degree 1, 2, 3, 4, 5. If you want to take a pic, if you don't want to write this down, you just want a picture of it, or I can scan it, that's fine too. If it's more organized for you to write it down and you learn from writing it down, then that's what you should do. Okay, so if we have a first degree term, that means the highest exponent is 1, So an example of that would be like y equals 4x minus 2. Okay, that's 4x to the first. So it's just a line. Okay, could be anything that's a line like this. So if we have a positive leading coefficient, my leading coefficient is 4. That means my line is going to kind of look like this. Because it has a positive slope, it's going to go up from left to right. That's what it's going to look like. As long as the slope is positive, my line is going to go up from left to right. And if I have a negative, so let's say it's y equals negative 3x plus 7. Well, generally, if that is negative, so this is the sketch of a negative leading coefficient, it's going to go down. All right, moving on to second degree. So that's a parabola or a quadratic equation with a leading coefficient that's positive. We have dealt with that before also. Do we remember if this parabola would open up or down? He says up with a big yawn. Yes, that is a parabola that opens up because of the leading coefficient is positive. So a sketch would look like this. As long as that number out front is positive, our parabola is going to open up. And then negative it just opens down. Okay, so far we might have been able to fill out this chart because we're pretty familiar with lines. We're hopefully kind of familiar with parabolas because we're dealing with them a lot this year. Now we're getting to something called a cubic. Third degree is called a cubic. This was quadratic. This is linear. So a cubic with a leading coefficient that's positive might be like 4x cubed plus some other stuff. Alright, so if the shape is going to be up, like a positive line, but then it might go down and then back up. So that's a positive leading coefficient, third degree. It's third degree because that's the highest x one. So negative, it's going to look like this, down, up, and back down again. So if you notice, if we have a first degree polynomial, how many different directions? We just go one direction like this. If it's a second degree, we go down and then back up. Two directions, down and up, or up and down. But this will tell you how many potential directions you could go. If it's third degree, you go three different directions. Up, or down, up, down. Okay, so that's how many wiggles it has. Up, down, what? Down, up, down. Alright, I'm going to stop there and then just keep recording because we're at 15 minutes.